discuss the density profile and temperature distribution for different values of magnetic parameter. And from these two figures, we observe that the velocity decreases, but the temperature increases for increasing values of magnetic parameter. This is due to we know that magnetic parameters work against the flow, and due to interaction between the magnetic field and the flow field, temperature increases. Since the velocity decreases with the increasing magnetic parameter, it decreases the inflation and increasing temperature within the boundary layer make a difference, temperature difference between the from the surface to the outside, and ultimately it decreases heat transfer from the surface to the cylinder, from the surface to the outside of the cylinder. This is the velocity profile and temperature profile for different values of stress work parameter, and from these two figures we observe that velocity decreases, but temperature velocity and temperature both decreases with increasing stress work parameter. And we know that the stress work parameter containing gravitational force and which against the buoyancy force, as a result motion of the fluid decreases, and we observe this from figure 6. This is the distribution and heat transfer effect for different values of stress of parameter. And from figure 8, it is observed that the distribution decreases, but the temperature increases with increasing values of stress of parameter. Now, the figure 10 and figure 11 shows the effect of conjugate conduction parameter on velocity and velocity profile and temperature distribution. And from this two figures, we observe from figure 10 that the velocity decreases and temperature also decreases for increasing values of conjugate conduction parameter. Conjugate increasing values of conjugate conduction parameter decreases, that means increasing values of conjugate conduction parameter raises heat transfer from the inner region to the outer region, and that decrease the heat transfer, and decrease heat transfer decelerate convection, and the results of decelerate convection is shown from the velocity from the figure 10. Now, the spin friction coefficient for different values of conjugate conduction parameter is shown in figure 12, and heat transfer for different values of conjugate conduction parameter shown in figure 13. From figure 12, it is observed that the spin friction decreases for increasing conjugate conduction parameter, and heat transfer also decreases for increasing conjugate conduction parameter. From the above discussion, we may conclude the following, that is, the velocity of the fluid within the boundary layer decreases with increasing magnetic parameter, stress work parameter, and conjugate conduction parameter. The temperature distribution increases for increasing magnetic parameter, while it decreases with increasing stress work parameter and conjugate conduction parameter. And from increasing spin friction coefficient along the surface decreases for all three parameters, and the rate of heat transfer for increasing stress work increases while it decreases when increasing magnetic parameter and conjugate conductive parameter. Thank you all.
Open for the discussion, please. Any questions? Yeah, I would like to thank you for your nice presentation.
Thank you very much.
Next paper, I would like to invite Martek 18, paper number Martek 182, Computation Drag Analysis over a Car Body by Professor M. Islam and Professor M. Mahmood. Yeah, I will call this 165 after this. What is paper number?
65.
Yeah, then this please present. The effects of temperature-dependent thermal conductivity and viscous dissipation on conjugate free convection flow on a vertical flat plate. Authored by ATM Rahman, NHM ARG, MM Rahman and MP Chaudhary. Please present.
Good morning. Thanks, Chairman, for presentation of my paper. I will express my paper title. Effect of temperature-dependent thermal conductivity on conductivity and viscous dissipation on free convection flow along the vertical flat plate. Objectives: the physical problems are presented mathematically by different sets of governing equations along with the corresponding boundary conditions. We consider the parameter thermal conductivity, radiation parameter, viscous dissipation parameter, and so on. Previous studies, Martin and Fox investigate the conjugate condition on a vertical surface. Koji and Truffaut analyzed the coupling of convection with laminar convection along a flat plate. Ken and Stein presented the thermal interaction between laminar film condensation and forced convection along a conducting wall. Method of solution: we use the finite difference method together with slab of physics. This is the typical model and coordinate system of the problem. Y bar is a Cartesian coordinate along the horizontal direction, and X bar is a Cartesian coordinate along the vertical direction. The plate is along the vertical direction. Here TB represents the temperature outside surface of the plate, and B is the thickness of the plate, and length is the length of the plate, is the temperature of the interface, and T infinity is the temperature of the fluid outside of the boundary layer. D is the acceleration due to drag.